Chapter 1 Binomial Distribution. The objective of this tutorial is to use the binomial theorem to find probabilities. The description of this objective is in page 5, section 1.2. And for better understanding, we are going to solve example 4. A biased coin has probability P to land heads when it is thrown. We have a coin. There are two possibilities, two events that might occur, head or tail. And that's what explains the use of binomial distribution. There are two events. When we say a biased coin, it means that a coin is thrown unfairly, where you are preferring the occurrence of one event more than the other. Concerning the questions we worked on in the S1, they were all considering a fair coin, which means that for a sample space you have two events, head or tail. Thus the probabilities are distributed likely, so probability of head equals 1 over 2 and that of a tail is 1 over 2 as well. But when a biased coin is thrown, the probabilities will not be equal. A biased coin has probability P of landing heads when it is thrown. Because they are not equal, consider from the given that probability of head equals P. The coin is thrown 10 times. We threw one coin 10 times. Required in this question to find the probability in terms of P of the coin landing heads in part A 10 times. Therefore, we threw the coin 10 times and recorded the outcome. In part A, we are asked about the probability that in all these 10 times the coin landed head. To begin this question, we shall first define the random variable. The type of the variable is discrete, as you are counting the number of heads. Consider the symbol x for this random variable. So, let x be the number of times the coin lands head. Thus, we are going to find probability of x equals 10. To find the probability, we consider for the first time appearing head, we have probability P. And as the experiment leads to independent events, the occurrence of the event every time does not consider the previous outcome. So we multiply by probabilities for the second, which is P. The same as for the 10th trial, so multiply P 10 times gives P to the power 10. It is important to know that looking for the overall outcome, we know that there is one arrangement for this set. They are all heads. So this is the only arrangement to be considered. Whereas for part B, we are asked about probability when the coin lands head 7 times. Thus, probability of x equals 7. As stated, probability of head equals P. Therefore, probability of tail, if given as Q, we know that Q equals 1 minus P, as the events head and tail are complement to each other. They are all the possible events occurring, so the addition of their probabilities equal 1. So the head occurring 7 times, therefore probability of head equals P to the power 7. The probability of tails occurring 3 times, therefore Q to the power 3. Still, for the answer we have to consider some basic property. If we looked at sample sets occurring, and for simplification, consider H for head and T for tail. So there are some arrangements that we may have. If for the first times we obtained head, and for the last 3 we got tail, it is possible to start for the first 3 by tail, and for the last 7 by heads. Or we can get head, then 3 tails, and thus continue with the heads. So as you can see, there are many possible arrangements. Not like the first part where we had one event occurring. When 2 possibilities appear, we shall consider possible arrangements, as we worked on in section 1.1. To count all the possible arrangements, we multiply by the combination C 7 out of 10. Or we can write it as parenthesis 7 out of 10, P to the power 7, Q to the power 3. Using the calculator to find the combination C, combination 7 out of 10, we get 120, multiplied by p to the power 7 and q to the power 3, where substitute instead of q 1 minus p as required from the question to give the probability in terms of p. So this is the answer of part B. Now for part C, following the same concept, required to find probability that the coin lands head 4 times. So probability of x equals 4 will be equal to the head occurring p to the power 4, tail occurring q to the power 10 minus 4, which is 6, multiplied by the combination 4 out of 10 to take into account all the possible arrangements. Writing it in the form of the parenthesis, using the calculator we get the combination 210 multiplied by p to the power 4 multiplied instead of q 1 minus p to the power 6. So that's how we found probabilities. First, by considering the events head and tail that are complement and independent to each other, and taking all the possible arrangements by using combinations where the two events occur.